Welcome to Trimester 2, Day 4 of Calculus. We have recently been looking at new differentiation rules that help us get over walls like two functions being multiplied together or one function being divided by another. Here's another wall, functions of this form. We have g of x equals 2x plus 3 to the 100th. This is challenging because we could do it, but it would involve first multiplying this out, which would be 2x plus 3 times itself 100 times. That is not something you'd ever want to have to do. There is a quicker way, and it's called the chain rule. Here's the technical definition. It says that if y is some function of f composed of g, meaning g, the function g, is plugged into f, which is called a composition of functions, then y prime is the derivative of the outer function at the inner function times the derivative of the inner function. Looks kind of complicated, but once you practice it out, it'll be really quick. It'll be really quick. Another way to say it is, let's say y is equal to some f of z. Y prime is the outer function evaluated at the inner function times the derivative of the outside. So for example, on this one right here, which is this first one we looked at, the outer function is something raised to the 100th power, so we'll let y equal z to the 100th, but we're going to let z equal 2x plus 3. When you plug z into here, you get the same function. So let's use the chain rule. The chain rule says let's take the derivative of the outer function, which is this yellow one right here. Y prime is therefore going to be equal to 100 z to the 99 times z prime. What is z prime? Z prime is just 2. What's the derivative of 2x plus 3? It's just 2. So that 2 goes right there. So you end up with y equals 100 z to the 99 times 2. But what does z equal? Z is equal to 2x plus 3. So you can plug that into there. And what do you end up with? Y equals 100 2x plus 3 to the 99 times 2. You could clean it up a little bit and make it y equals 200 times 2x plus 3 to the 99. That is a lot better than multiplying the whole thing out. That is a lot better than multiplying the whole thing out. Another way you can kind of see it too is you look at the original function and you say you take the derivative of the outer function, which is the yellow part, so that 100 dropped to the front, and then you reduce it by 1 to make it turns into 99, and then you multiply by the derivative of the inside, which creates the 2. So let's keep on practicing here. What about here? So we can do it out the longer way, which is writing it as y equals z to the 7th, and z is going to be equal to 4x squared plus 1. So what does that mean y prime is going to be? Y prime will be 7 times z to the 6th times z prime. But we know from here, what does z prime equal? Well, that's equal to 8x. So that's going to go right there. And then we also know that z is equal to this whole thing, so that can go right there. So what do you end up with? Y prime is equal to 7 times z, which is 4x squared plus 1, to the 6th power, times z prime, which is 8x. You can clean it up a little bit, and you get 56x times 4x squared plus 1 to the 6th. Again, the outer function is right here, the yellow part, so that 7 drops to the front and becomes a 6, and then you have to multiply by the derivative of the inside, which is 8x. Let's try another one here. You have y equals, again, the outer function right here, very similar to what we just did, so we have z to the 5th, and z is equal to 3x cubed plus 2x plus 1. So y prime is going to be 5z to the 4th times, and I don't like putting that dot in for multiplication, I'll just use parentheses, times z prime. Well, we can do the substitution now. We end up 5 times 3x cubed plus 2x plus 1 to the 4th times z prime. So what's the derivative here? Z prime is equal to 9x squared plus 2. So that's going to go right there. 9x squared plus 2. And you could multiply this out a little bit, but your whole goal, remember, is to get something in terms of x. You don't want z to be in your final answer. So this one looks different, but it's really not. You have a square root. Square rooting something is the same as 2x squared plus 3x minus 4 all to the 1/2 power. So you could say y is equal to z to the 1/2, so that and that z is equal to 2x squared plus 3x minus 4. So we know y prime is equal to the derivative of this. So it's 1/2 z to the, what's 1 less than a half? Negative 1/2 times z prime. Remember that z prime has to be kicked out. And how do we figure out z prime? Well, z prime, haha, is 4x plus 3. And then you substitute back in. So you have y prime is equal to 1/2, whereas z, what's that big thing? 2x squared plus 3x minus 4 to the negative 1/2 still, times z prime, which is 4x plus 3. Yes, this should seem repetitive. You could multiply this times this, but I'll leave it like this for now. Once you get down to, in terms of x, you were technically done. You might need to clean it up a little bit. So what about this one? Let's follow the same pattern. Y is equal to e to the z, and let z equal 2x. So y prime is equal to e to the z, because that's the derivative of e to the z, times z prime. Oh, I shouldn't use that. I don't want to use the dot. Because what is the derivative of e to the z? It is e to the z. But then because of the chain rule, you have the z prime. And then what is z prime? Well, that's just 2. The derivative of this is 2. So that goes there. So you have y prime is equal to e to the z times 2. But we don't want z in the final answer. We instead want to write 2x. So we end up with y prime is equal to e to the 2x times 2. And just for your knowledge, I like the coefficients going up front. So 2e to the 2x. That's a lot clearer to me than the original line. So what about this one? Not too much is new. You got this 5, and that 5 is just kind of along for the ride. It's on the outside, so you can just keep it on the outside. So first, let's write it in terms of z. So it's going to be 5e to the z. And if we do it that way, z is 3x cubed. So now we need to do the derivative of y prime and multiply it times z prime. So that's going to be y prime is equal to, well, the 5 is along for the ride, and the derivative of e to the z is e to the z. But then you need to multiply it by z prime. Z prime is going to be 9x squared. So what do you end up with here? You do the substitution. You get 5e to the z times 9x squared. But again, you don't want that z to be in your final answer, and you know that z is equal to 3x cubed. So what do you end up with? Y prime equal to 5e to the 3x cubed times 9x squared. You could leave it like that, but if you wanted to do that further, y prime would be 45x squared e to the 3x cubed. Some of you at this point might have noticed that you could skip some of these steps. You might be able to, some of you might be able to go straight from here to there, and we will discuss how you can recognize how to do that. But for now, please make sure that you know how to break it down into these two pieces, at least for now. Here, this should be a product right here. So that should be a multiplication. So in this case, we have to use the product rule because we have the product of the yellow function and the blue function. So we know that y prime is going to be the derivative of the first, so 2x times the second, plus the first times the derivative of e to the x squared. And the reason I didn't do this one is we need the chain rule to do this. We need the chain rule to do this. So we use the product rule to begin with, and now we have the chain rule inside that. So this thing is still y prime is equal to 2x e to the x squared. That's there. And then plus x squared. But what's the derivative of this going to be? We need that right there. So let's go over to the side here and see what that's going to be. Well, we're trying to find the derivative of e to the x squared. So that's y equals e to the z, where z is equal to x squared. So we do our chain rule, which is y prime is equal to the derivative of the outer. Remember, the derivative of e to the z is e to the z. But now we need to multiply it by z prime. Z prime in this case is 2x. So that goes right there. So you have y prime is equal to e to the z times 2x. But z, remember, is x squared. So therefore, y prime is equal to e to the x squared times 2x, which is exactly what we wanted. So this goes right up there, which is e to the x squared times 2x. So that would be our final answer right here. So this one example is there to show you the chain rule could happen inside the product rule.